All right, let's do the ambiguous problems. So once again, you'll know automatically if there are going to be two triangles if the short side is across from the given angle. Okay, so in this case, the given angle is 35 degrees, the short side is 6. We will have two triangles. So also just to kind of see a visual of what's happening, let's say it looks something like this. This is 6. This would be 35 degrees. This is 8. So that's beta. We are going to need to look for beta first when it comes to any of this, or you need to find the missing angle across from the side given to you. So whether it's beta, gamma, or whatever. We have side B, so we're looking for beta. Okay, so let's go ahead and set that up, but there are going to be two triangles. So down here, I'm going to go ahead and set up, we've got our beta 1, we've got our gamma 1 we'll need, and C1 for the first triangle. And then we've got beta 2, gamma 2, and C2 for our second triangle. So there's going to be 6 pieces of information you have to find. Okay, so let's go to triangle 1. So for triangle 1, let's go ahead and find beta 1. So sine of beta 1 over the opposite side, so 8, equals sine of 35 over 6, because I'm going to use that complete ratio. An easy way is just move the 8 over, multiply it over. So sine of beta 1 equals 8 sine of 35 over 6, and then apply the inverse. So beta 1 is going to equal, here we go. So we're applying the inverse of all of this. I'm just going to be lazy and just, we know what we have to type in. So let's go ahead and type that in as 8 sine of 35, and then, I hope I typed it in wrong. Type it in that way, 8 sine of 35 over 6. And we get that beta is approximately, 49.9 degrees. Okay, so from there, what I usually do is I find my second beta. So remember, if this is 6, the other triangle is going to look like this, or it's smaller, so we can swing that in. So this is also going to be beta. Both of these, it's an isosceles triangles, both of these are beta. So to find the beta for this triangle, you just do 180 degrees. Let me do my triangle 2 over here. You do beta 2 would be 180 degrees minus our beta 1. So this right here. So 49.9, which is 130.1 degrees. So I'll go ahead and put that down. Okay, let's go ahead and finish finding everything for the first triangle though. So next thing I would do is find my gamma, and I just do that by taking 180 minus the two angles. So 49.9 minus 35, minus 35, yeah. So we get 95.1 degrees. So if we do the same thing for the second triangle, gamma 2 would just be 180 minus, this time 130.1, because we're using this one, and still minus the 35. And you would get 30.1, 14.9 degrees. So 14.9 degrees. And then the last thing I would need to do is find side C. So this was like step 1. This was like step 2. So step 3 would find side C. And I would go ahead and use, so we've got sine of, we got to use gamma. And we're doing this for gamma 1, so 95.1 over C1. And then I'd use our original information because it's going to be the most accurate still, or there's no rounding we've done. And then we can use our little quick trick. Since c is across from sine of 35, you'll be dividing by sine of 35. And we'll type that in. So we've got 6 sine of 95.1 over sine of 35. And you get about 10.4. And then for C2, rather than do all that work again, all you have to do is switch out the gamma, because we aren't using gamma 1, we'll use gamma 2. So we'll use 6 sine of 14.9. So I'm just switching those out. I should use the yellow. Whoop, there we go. Over sine of 35. So I'll just switch those out. Let me go ahead and do that. And this to be 14.9. And C2, it's actually a lot smaller. You get 2.7. Which should make sense because we went this direction, right? On our triangle. So there is your information. So those are like the nasty ones when you have to do 2 triangles. Let's go ahead and do another ambiguous case though. So this one, we want to again have alpha and side A. Notice how side A is the bigger side of the 2 given to us. That means you're only at most going to have 1 triangle. It could be 0. You'll know when you solve, because if it's 0, you're not going to be able to get an answer. It'll give you an error. So let's go ahead. There should just be 1 triangle. So we're going to solve for beta. So we're going to do sine of beta over 2 equals sine of 40 over 3. We're going to cross, or just multiply by 2 actually. So just like we did on the last problem. And then apply the inverse. Which I'm going to be lazy and I'm just going to be like, we're just putting all that in. Okay. So let's put that in the calculator. So we've got 2 sine of 40 over 3. And you get that beta is equal to 25.4 degrees. Which, by the way, this is another way that people know that there's not going to be 2 triangles. If your angle is smaller than the given angle, so if the angle you just found is smaller than the given angle, that's another thing they'll always look for. So that's why we know it's 1 triangle. So let's write out the stuff we need. We need beta, we need gamma, we need C. So 25.4 degrees. Notice I didn't draw a triangle out this time. You don't have to draw the triangles. It can just help. But at this point, you have 2 angles. So we're going to find gamma by subtracting 40 degrees and 25.4 degrees from 180. And what was it? 40 and 25.4. And you get 114.6 degrees. And then to find C, you're just going to be using gamma, so sine of 114.6 over C has to equal sine of, and I'm going to go back and use the 40 over 3. So I always go back to this stuff since it was the original information. And then we've got, so I should label this as 1, step 2, step 3. So then we've got, once again, you're going to divide by the one across from the variable. So we're dividing by sine of 40. So say 3 sine of 114.6 degrees. Should have put those in parentheses. And we can just type that in. (114.6) sine of 40. And you get C is about 4.24. Okay, so you haven't seen the no triangle case, so you probably will guess that this is probably the case where we have no triangles. So same idea. This time we've got gamma and side C. So notice how the shorter side is across. So every time the shorter side is across from the given angle, that always can be one of two different scenarios. That either means that there's no triangles or there's two triangles. So those are really the ones you watch out for. And we're going to go ahead and say sine of 50 over 1 is equal to sine of alpha over 2, which I usually write the other way, so I will do it the other way. Not that it really matters. Sine of alpha over 2. And I'm going to go ahead and multiply both sides by 2. So you get 2 sine of 50 degrees over 1, which you don't even need to put it over 1. And then you get alpha is equal to the inverse. You just apply the inverse of all this. Once again, I'm going to be lazy and just be like, we're putting that all in, right? And so when you type it in, though, what you're going to notice is you get an error. The reason you get an error, or it says it's undefined, so it'll say one of two different things. Either it's undefined or there's an error. If you get that message, though, there is no triangle. And there's a way you'll know it's going to be undefined. It's if you type this value in, 2 sine of 50 divided by 1, before you apply the inverse, it's going to be greater than 1. And anytime it's greater than 1, it's not actually, you're not going to have a sine value that's bigger than 1 on the unit circle. If you think of the parent function for sine, like so, it only goes at most up to 1, and then or down to -1. So if you're ever above +1 or below -1, it's automatically going to be undefined when you apply the inverse. So that's what's happening. That's why it's not a triangle. And there's your last scenario.